Alright, welcome to Chaka Context. Now, in this tutorial, I'll be putting us through. I should have been putting us through Steelworks, right? Okay, but when we go through the question, we'll see what we are going to do. Alright, now this is the question for Nigeria Institute of Quantity Surveyors Test Professional Competence Examination. You can see it is May 2025. Alright, so we'll be looking at it. The question is on steelworks, concrete works, and steel works. Alright, so why I say should is because I will be breaking the video into two to reduce the length. I had done it before. The video was going over about 1 hour plus, so I decided to break it into two. Concrete work separate and steel work separate. So we'll be treating this as concrete work now only, and then in the next video we'll be looking at the steel works only. Alright, now look at this is a question. Drawing reference this shows a sketch of the structural drawings of a proposed factory development at Asaba, Delta State. The client wants the contractor to quote at this stage, even as drawings are being finalized, so that he can award the concrete, structural steel work, and roofing to one contractor, and requires a tender document for these items of work. In view of this requirement, you have to do the taking of and prepare a draft bill of quantities for the following work items. I'll be doing the taking of, I won't be preparing the draft bill. I have taught how to prepare draft bill over and over again. So please go through the previous video on how to prepare a draft bill. I won't be doing any draft bill here, only takeoff. Now, takeoff quantities for concrete works in column bases and columns, structural steel work, roof covering. See, concrete work in column bases and column. They didn't say reinforcement and formwork. This is the exam question, right? But what we'll be doing concrete reinforcement, formwork, and then we'll do other videos also. Prepare a draft bill. Alright, so this is basically what we'll be doing in this very video. Now this is the drawing here. This is the drawing. Let me rotate it for better view. Now this is what we have. This is drawing of the factory. Of course, these are steel works. Alright, but we're not dealing with steel works here. We're dealing with the concrete work items here for column bases and columns. Now this is a column basis, column base one plan, right? The column base is 1500 by 1500. Please let's study the drawing together very well. 1500 by 1500. Now the column base reinforcement is Y12, right, at 200 center to center, both sides. It says only bottom. B means bottom, C means center to center, Y means high yield reinforcement. 200 is the spacing. All right, now this is the detail of the column. It is 400 by 400, right? And the reinforcement says, see the section here. It says 8Y16. It means we have 8 number reinforcements here. See this dot like small zeros. 1 2 3 4 5 6 7. Okay, it is shown here also. 8Y16. That is 8 numbers, 16 diameter, high yield reinforcement steel bars. These are the links, right? See this one here that goes round. Nafuya, that goes round like this. Yeah, that is what you call the links or stirrups. Y10 at 200 center to center. That is Y10. The Y means high yield reinforcement. 10 there is the diameter. 200 is the spacing. C to C means center to center. Now this is the detail here. The height of the column is 200. The height of the base, depth of the base is 300. The depth of the stub column is 200. The thickness of the base is 300. Now you see there's a blinding of 50 mm, right? This is basically what we have for the concrete. So we used to prepare do the takeoff for the concrete works. Now let's quickly come here. All right, don't worry, I separated it. I have separated it rather. Now this is what we have. This is the proposed pre-development at Asaba Delta State. This is drawing number. All these are in the question, but my SMM is not in the question, so I'm putting it there so that my examiner will know this is what I have. But of course, if you're preparing, if it's an office work or a personal work, you don't need to do all this, right? But if someone is going to vet your work, a superior is going to vet your work, you have to give the project details properly and put date so that they can easily make reference to them. These are takeoff list. Concrete reinforcement formwork. Now I've done everything including the steel. Then you have the steel works, which we'll be looking at in our next video. All right. So basically, we'll just stop at concrete works, concrete reinforcement, and formwork. So concrete works. Concrete work is in section 1.11 in the BESMM 4R. BESMM 4R stands for Building Engineering Standard Method of Measurement 4 Revised. R stands for revised. So concrete work, the first concrete work there is the blinding. Now we know the length of the base is 1,500, the width is 1,500. The concrete there, blinding is 50 mm. 50 mm, you can see it here, 50 mm. All right, so that is what I just did here. 1.5 by 1.5 by 0.05. We have 15 number column bases. 15 numbers, 1 2 3 4 5 times 3, right? Okay, 6 7 8 9 10 11 12 13 14 15. So we have 15 numbers. That's what you have. This is what we have. Of course, by now you know how to measure these things, right? So we're just presenting this as a further tutorial to add to what you already know. This is the BSMM reference, right? You can take your BSMM, you can check them out. 1.11.1.1.3.1 describes the blinding works. Then after the blinding works, of course, we have reinforced concrete, because the blinding is a mass concrete. Now we have the reinforced concrete. All right, reinforced concrete, of course, in horizontal work, because you're pouring it in bases. All right, horizontal work grade 30, 300 mm thick. In column structures, you see there are BSMM 4R reference. Right, now the base is 1.5 by 1.5. The thickness of the concrete is 300 mm. All right, I already show us here. This is it here, 300 mm. So this is basically we have 1.5 by 1.5 by 0.3. I've calculated the measure takeoff for the concrete in the column base. Now you can see I didn't square. All right, if it was a work in the office, or I am preparing something for someone, I will square. But in this case, we have to prepare a draft bill. Like I said earlier, if you're preparing a draft bill for an exam situation, you don't square. You don't put quantities. You don't put rate. You don't have an amount, except you're asked to prepare a detailed bill. All right, we'll go forward. Now, the next concrete is the concrete in the column, the stub column itself. Any column below the ground is called stub column, or you call them pedestal column when they are big. Right, you call them pedestal columns or stub columns. All right, so this is basically, see the depth here is 1,200. All right, quickly we'll come here. It is 0.4 by 0.4 by 1.2. It is 400 by 400 by 15 numbers. So with this, we have calculated all the concrete work. For in that, assuming this is an exam, we say concrete works. They didn't say measure reinforcement or formwork. You are done. It is concrete works. Shikena. Alright, so I just wanted to show further. That's why I wanted to do the reinforcement and formwork separate, so that I don't have a separate video later in the future and say that I want to do concrete and reinforcement and formwork. Let's just do it one at once now and get it over with. Now the reinforcement. So we've been able to see the concrete. Right, they are meter cube item, length, width, depth. That gives it a cubic meter status. All right, so reinforcement, we want to look at the reinforcement now. If of course I just made a sketch here, this is what we have. I just tried to make this sketch here. All right, this is what we have. This is the reinforcement, and it is 1,500 by 1,500. All right, now you agree with me, before I will see this reinforcement, right, because it is assumed to be inside concrete. Before I can see it, I have to break a cover here, so I can see this reinforcement. Now you can see it is not touching this edge, neither is it touching. As a matter of fact, it is bent at both ends. That is why you say less cover. So less cover is not a mysterious thing, neither is it fictitious, right? It is assumed that the reinforcement is inside the concrete, and before you can see it, you need to break part of the concrete. That's what we mean by cover. And it has been given in the question that Where Adam, see, don't worry, you can see it from here. Covers for reinforcement 25 mm, while bends is 75 mm. Koban Kabani. Yawa. Right? So this is basically the things we'll be using. They say make reasonable assumptions where necessary. So also wherever that is necessary, we are going to make. But what is given, we have to use. Okay, so this is basically what. So for me to see this reinforcement, I have to less cover. See, I put it there. Length is 1500. Now I want to less cover 25 mm times 2 because this side and this side. All right. Then I have to add bend. Now you can see here there's a bend here. See this blue line here, tiny. See it here properly. Oh, sorry. This is the bend here. Oh, here. You can see it. It is bent on both sides. And they say it is 75 mm. So by 2, this is 1500. I less cover, which is 25 times 2. I add bend. You're seeing it here. 75 times 2, which is 150. So 15 minus 50 plus 150, I have 1600. Abibeko. Alright, so of course I need to know the number of bars because we're not given the number of bars, but I know this length is 1500 and we're told that the spacing it is at, let's see, we're told that the spacing is at 200. We saw that before, 200 center to center. Alright, so all I need to do is 1500 divided by 200 plus 1. I'm adding 1, of course, you know, because where I'm starting from, I need to put one reinforcement there because I'm dividing with spacing. That is why we always add 1, because where you're starting from, you need to put 1 there before you now start counting. That's why you see always plus 1. All right, I hope that explains plus 1 plus 1 plus 1. You'll see all the time. So 1500 divided by 200 plus 1, that gives us 8.5, which is 9. Right, so we already know the length of 1 to be 1600. So this is 1.6. right, this is it here, 1.6. all right, we have 9 numbers. We have times 2 because see 1 and 2, they are both 15 by 15. Then we have 15 number columns. All right, now this is it is in tons. Is in tons. It is 12 mm bars. That's why it is 0.888 over 1000. I have taught this before in one of our videos, how you can the formula, and of course I know you know it, right? But if you don't know, please make reference to our videos and see, just brush up so that you can become better and better. There's a formula for this. Diameter square over 36 times 0.222 is what I use always. Some other persons have different formulas. The ones you can manage to have in your brain always, please do and use them. All right, so that is it. It's in ton. 0 times 0.88 is the weight in kg per meter of Y12 divided by 1000. It is in ton. If I multiply by 0.888, I have it in kg. Right, divided by 0.888 alone means I'm having my answer in kg. Then if I divide by 1000, that means I'm converting it to tons, because 1000 kg is 1 ton. I've also explained that before. I won't be doing that again in this video so that we don't have too lengthy a video. All right, after the base, we go to the columns, the reinforcement in the columns. Now I've been told that the column is 1200 millimeter high, right? That the depth is 1200. That is what we have. Now let's come here. This is what we have. 1200 up to this point too, right? But see, it is extending down here. It is even having a bend, right? So if I just pick 1200, then I might just have been making a mistake. Now if you look at the top also, there is even a bend at the top. So if I just say 1200, and I'm making a hell of a mistake. All right, so you need to be very careful. So this is 1200. I need to add this. I need to add this bend. I need to add this bend to have the total length of that particular reinforcement. And of course, you see, it's already inside concrete. So I need to I need to less cover. I refuse to be distracted. I need to add cover. Less cover rather. All right, now let's see it here. I said it is 1200. Add column base. Right, add column base. This is how you do it. I add this column base 300, but of course you will say but the reinforcement is not getting to the bottom of the column base, right? You're right. You're very right. Okay. Now that so you need to less this distribution bar. That's this bar you calculated here because the column is sitting on it. So that's why I say less distribution bar 100 mm. Right? Another person can say, but the distribution bars are they even 100? They say 12 mm diameter. 12 mm. Alright? Less distribution bar 100 mm. Then this is column based distribution bar. Okay, this is 1 2 here. Let's start with this. Let's cover, which is 25 mm, right? Because I'm dealing with one, I'm working for one reinforcement at a time, so that's why it is not 2 times. It is not say on both sides, right? Let's 25 mm, which is the cover, and then I add. That's why you see it. If you see less, you see minus, you see negative sign in front. Add 300, and then for me to get to where the reinforcement is, I less distribution bar, right? So that's 100 mm, and then add bent. This is 2 by 75. Now you know I'm working on Excel. If it were paper, if I'm working on paper, I would have been able to write. Alright. Otherwise, I'll scatter everything I have here. If it's paper, I'll write it right. So that's why I have to write these ones at the top. Right. So minus means this is cover. Add. You see this one here, column base. Then I less distribution. See what I mean by that. See, let me increase this. Right, enough for you now. Yo, wow. This is clear okay now. Okay, see, this is the column base 300 mm. Right, see this, see where the reinforcement is. I need to less this space where you get to where the reinforcement is. Right, 100 mm. All right, it was not given. Generally, it is 100. Another person can say 200 mm. But if you say 200 mm, look at the whole concrete here. Alright, another person can say 50 mm. Another person can say 25 mm. Because it is not cover, it is more than cover. See, you have a distribution bar, then you have a space in the distribution bar. So it is an assumption. So when if it's an exam situation, you are assuming it's okay, this particular is what I used. Alright, so take note. So we used ours as 100 mm. So add bent. See it here, it is bending at both ends. See the one bent here, see another bent here. All right, so that's what we have. 1525. All right, that's 1.53. Now we have 8 numbers. We are told that it is 8y16. 8y16. All right, so this is what we have here. 8 numbers in one column base times 50 in one column, rather one stub column, times 15 numbers stub columns. That's how you get 120 here. Okay, now of course, after the reinforcement in the column, you have the links. We saw that here. This is the link, right? Tying the reinforcement in the columns together. The same thing we did, we're still going to do. Of course, if I can see this link, I need to less cover. If I less cover, I need to add bent because it is very obvious here. Okay, now let's come back to a calculation. All right, the column is 400 by 400. Cover, okay, I wrote it down here again. Cover is 25 mm, bent is 75 mm. Okay, let me remove this so that, all right, because we already have it there. Am I right? Yes. Okay, this is what we have. The length is 400, the width is also 400. Cover 25 mm. This now we have 400 by 400, 4 sides. 1 2 3 4. All right, that's why I see 400 by 4 for 4 sides. Let's 2 cover, add 2 bent, add 2 bent. Where did I even do that calculation go? Okay, this is it here. This is 400 by 400 4 times. Let's cover for 2 sides, then add bent. All right, I could have still done it vertically. We will say this is oh, it's already okay. I can have it here. 400. Let me make it open. 400 times 4. I'll say less bent minus 2 times 25. It will not go, it will not go. Okay, it can go. This thing will take my time. It will go like this. It will go like this. All right, this is less cover. Then I add bent. All right, then that's all. All right, let me put this, let me centralize it. All right, so this is basically what we have. That's what we have inside here. 400 times 4. I less cover, I add bent. So that is what we have there. All right, this will give us the total length of the reinforcement. That is it here. It will give us 1700. Where is that? 1700. Let me centralize it. So this will give us OTRO. That said is not going again. All right, so this will give us 1700. All right, so that's what you have here, 1.7. All right, so how many numbers is going to be there? How many numbers? Because you know you have it will be here. Let me show us quickly. You have it here, here, tying all these together. Now you see these dotted lines, they refer to these dot. They are the links holding these together. So how many are we going to get? We know this here to be 200, and the links is at 200 center to center. So all I need to do is 200 divided by 200 plus 1. All right, so that's what we'll have here. 200 divided by the spacing plus 1, that gives us 6 number, plus 1, that gives us 7 numbers. So multiply by 7. Now this is not correct. Multiply by 15 numbers. We have it for 15 numbers. Go back cover. To ankani. Okay, it will not go like this. What do you mean? Where am I at? Yes, Kilibi. Where am I? Okay, I'm here. All right, this will be times 15. So this is what it's gonna be like. All right. See, this is steel. Let me make it concrete. Concrete MB sheet. All right. So this is what we have. This is basically what we have. All right. So this is the link. Now we'll go to the formwork. Of course, you know we have concrete reinforcement formwork. All right. Formwork is to the base and then to the stub column. The base and then the stub column. All right, now this is the base. It is 1500 by 1500 by 300 mm thickness. All right, now okay, I'll correct something here now, but let me explain it. The BSMM 4R says that when the depth is less than 500, when the thickness is less than 500, state the width. State the width. You can confirm it. Right? When the depth of a concrete is less than 500, just state the width, put it in meters. Right? So that's why I said I want to correct something here, because I already corrected this here. This is 1.5. Right? It is 300 mm thickness, so it is less than 500. So it will be in meters. See the unit here. The unit here, let me put this in red so you see it. The unit is already in meters. Right, so that one is not supposed to be there. Let me remove this also. Okay, this I should be okay. Let me put this here. All right, so you can check it from your BSMM. If when the depth is less than 500, state the width, right, and let it be in meters. Unit is in meters. All right, the same thing for the stub column. It is different. For the stub column, total size of attached stub column, it is in square meters. This is in square meter square. Is in square meters. All right, I want to make this 2 here a superscript. I highlight. See my cursor here. See this drop down here. I click. I come to superscript. Bam. You forget. All right, so basically this is how you do that. I've explained this in one of my videos, one of our videos also, our tutorial videos also. Please do and update yourself. All right, so this is what we have: 1.2 by 0.4 as for one side, but we have it for 4 sides, and we have 15 number columns. That's what you see here, by 4 by 15 by 4. I'm using Excel, right? If I were to be using book, like you'd have said, I would have put by /4/15, but this is Excel. That is why you're seeing it like that. All right, so this is concrete, reinforcement, and formwork. I know you know this, I know you know it, right? But I just needed to separate it from the steel work so that it doesn't become unnecessarily too long. This is how you measure concrete works for columns. Other concrete also becoming like pad foundation, raft foundation, right? We've done piling. I've done a video for piling. So raft foundation, pad foundation, they are still like what you just did now is a pad, right? But for the foundation as a whole, we are going to treat it also as a video. I hope this helps you in your academics. I hope it helps you in your professional career. I hope it helps you also in the next job you are going to get. This is Chaka Context. I'll see you in the next video. Thank you.